In this video, we're going to talk about quadratic functions and their graphs. Let's start with what a quadratic function is. So this is a function of the form, and we actually have two different formats that we're going to see. Remember, f of x is just a way to show that it's a function, but it's the same as a y, right? So y equals ax squared plus bx plus c. That's called the general form. What makes it quadratic is the x squared, right? The highest power on x is a 2, and that changes some things. The second format, same, this f of x we could think of as a y. This one is factored, right? So I have a, but then I have in factored form x minus h squared plus k. If I were to FOIL this out, I would still have an x squared, so it counts as a quadratic. This is called the vertex form, and we'll talk about why that is in a minute. I know there's a lot of variables here. All of them are going to be replaced with numbers when we're working. The only one criteria that we have is that the a cannot be 0, and that's because if a were 0, we wouldn't have an x squared, and the x squared really is what makes it quadratic. The most basic quadratic function is y equals x squared. So I wanted to take a second and graph this one with you. Okay, we're going to talk about all the parts and how to make the graphs along the way in the video, but to start out, we can make this one with that standard set of x values. It's centered at 0. And so we can pick a couple numbers smaller than 0 and a couple numbers bigger. And it would be fair to ask, well, how do you know it's centered at 0? Okay, and we're going to talk about that in a minute. So for now, you're just going to kind of have to trust me, okay? Each of these x values we want to plug into our formula, so we square them. It's important when you are plugging in numbers to put them in parentheses. So that negative 2 squared, negative 2 times negative 2 is going to give me a positive 4. That's really important to get the right shape. Same for all of these, right? Negative 1 squared is going to give me 1. 0 squared is going to give me 0. 1 times 1 is 1. 2 times 2 is 4. All right, so if I plot these, again, 0, 0 is the middle for this parabola. On the left, I have negative 2, 4. Negative 1, 1. And then on the right, I have positive 1, 1. And positive 2, 4. This is a bowl shape. It's called a parabola. It is symmetric. Kind of looks like that. Okay, so before we talk about how to graph any others, we want to kind of talk about all the important pieces of this graph. So, let's see if I have another color. There's an important point, I'm going to start with that, and that's the vertex. So the vertex is the maximum or minimum point. For this graph, 0, 0 is the vertex, right? So for us, that's 0, 0. In general, we use h and k as variables to represent the coordinates of the vertex. Why mention that? Because we have an h and a k up here in the vertex form. And so we're going to talk about that in just a minute. Okay, the axis of symmetry is a line that divides the parabola in half. It's a line. Okay, and it's always going to pass through the vertex, and it's a vertical line. So it has equation x equals h because it's vertical. We've talked about those in the past, although it's been a while. I'm drawing it in as a dotted line. basically this is a line that if I were to slice it in half to get two equal sides, this is the line I would slice it on, right, to cut it in half. Okay, the next thing we're going to talk about refers to the a in both equations. This is the same variable a. So if I have a 5 here and I rewrite it in this form, it's still going to be a 5. So this a does affect the shape of the graph in two ways. So first, it affects the orientation. So if the a is positive or greater than 0, then my parabola is going to open up. Okay, and when it opens up, notice I'm going to point back to the vertex here, right? The vertex will be at the bottom, just like the one we just drew. So if my parabola opens up, then the vertex is a minimum, right? It's at the bottom. If that number for a is negative, then basically my graph gets flipped upside down. And so now my parabola opens down. And the vertex now is a maximum, right? It's at the top. Okay, so positive or negative number affects, does it open up or open down? The number part of a, now we're going to disregard the sign because we've already addressed that up here. So I put on the absolute value bars here so that we're not talking about it being positive or negative, we're just talking about the number part. So if a were -2, right, I'm not talking about the negative, I'm just talking about the 2. So if that number is bigger than 1, then my parabola is going to be vertically stretched. And if I vertically stretch a parabola, it's going to be more narrow. Kind of like a tall and skinny parabola, right? Sort of like that. Yeah, so that's going to happen if this number part is bigger than 1, right? If the number part is smaller than 1, then I'm going to say it is vertically compressed. And what I mean by that is it's almost like we set something heavy on the parabola and we squashed it down and it became this really flat looking, wider kind of parabola shape, right? So this would be a scenario that made it tall and narrow. And if a were, say, -0.5, right? I'm not talking about the negative. Talking about the 0.5. If it's a number like a fraction or a decimal that's smaller than 1, it's going to create this kind of wider shape. So the value of that a variable affects the shape of the graph and the orientation of the graph. So that can kind of give you an idea of what to expect. All right, so to make the graph for a parabola, the easiest way to do it is to first find the vertex and then kind of organize your x's around the vertex, that middle point. So there's two ways to find the vertex, one for each form. Okay, so this, I don't have it written here, so I'm just going to pencil it in again, but this is called the general form. So if it looks like this, there's a formula we can use, and it relies on a process called completing the square that we'll talk about in another video. But it turns out if I take this and I reorganize it into that factored form, the x value of the vertex turns out to be -b/2a. Okay, so we can use that formula to find x, and then there's a formula for y, but it's usually just easier to take whatever number we get for x and to plug it in to find the y. So let's try that out on this one. So we have, I wrote it as a function, but these are the same, right? F of x and y are the same. I'm going to put the y in there. So the coefficient for x squared is the a, the coefficient for x is the b, and then the constant, or the number, just plain number at the bottom, is the c. So let's write those out. It's probably not bad to practice that. So the a would just be -1, the b would be 4, and the c would be -3. Notice I don't have any variables here, right? There's no x's. I'm just taking the number in front of the x's. So to find the vertex, we're going to use this formula. So x is the opposite of b, so -4 over 2 times a. So that gives us -4 divided by -2. A negative divided by a negative is a positive. Right, so this is my x value. Now I want to take that x value and plug it into my formula to find the y. So y is negative, and then 2 squared plus 4 times 2 minus 3. If I calculate that out, this is going to be -4 plus 8 minus 3. So that's like 8 minus 4 would be 4, minus 3 would be 1. All right, so if I put that together, my vertex is going to be the point 2, 1. Okay, so if you need to rewatch that process again, this is a good way to find the vertex, right? Especially if I have this general form where it's not factored. And I use that minus b over 2a. Once you've found the vertex, then you can make the graph. So the vertex is that center point. So we're going to put it in the middle of our t-chart. We're going to pick x values around it. So a couple of numbers smaller and a couple of numbers bigger. And then I want to plug those numbers into my formula. I've lost my formula. Let me copy it down right here. Okay, so if I plug in 0, I'll have 0 plus 0 minus 3. If I plug in 1, let me write it down the bottom. I'll have -1 squared. Notice the negative's on the outside. Plus 4 times 1 minus 3. So that's -1. And -3, that's -4 plus 4. That's 0. Okay, now the parabola is symmetric, so there is kind of a shortcut you can use. If I plug in 3, I should get the same thing I got when I plugged in 1 because they're on opposite sides of the vertex, that middle point. All right, let's try it out just so you don't think I'm crazy. This would be -9 plus 12 would be 3. And 3 minus 3 would be 0. Okay? Same thing's true if I plugged in 4, right? I'm not going to write that one out. You can write it down if you like. But if I use 4, 4 and 0 on the opposite sides of the vertex, I should get -3. Feel free to check me. Okay? All right, let's plug these in, or plot these rather. So I have 0, -3. All right, wait a minute. Before I go any further, is this parabola going to open up or open down? Remember our a was -1, so it's going to open down, right? good to know that ahead of time so that when you plot these points, it makes sense as you're plotting them, right? So 0, -3, 1, 0, 2, 1, 3, 0, and then 4, -3. It's opening down, which makes sense with all the points we have right here. And I have the same shape, that same parabola, it's just moved to a different place on the grid. Okay, so the process for graphing a parabola is going to be the same every time. How we find the vertex might be different, but we're always going to put the vertex in the center and pick x values around it. So I get both sides of this bowl shape. All right, so this one was in general form. Now let's take a look at an example in vertex form. Okay, so this is vertex form. Notice it's already factored. That's kind of how I can identify it. So for the vertex form, finding the vertex is kind of easy because that's why it's factored. That's why it's called vertex form. All I have to do is be able to identify what is standing in the role of H and what is standing in the role of K. Right, so I want to compare these two together. Okay, so in this one, I have x minus h squared. In this one, I have x minus 1 squared. So the h, what's playing the role of h, is 1. Up here, I have plus k. Down here, I have plus 2. So what's playing the role of k is a 2. All right, the k is always going to take on the sign that you see here, right? It's a plus 2. I have a positive 2 for my k. The h, because there's a built-in negative in the formula, is always going to look opposite in sign from what I see here. So I see minus 1, but my h is actually positive 1. And that's going to stay that way for a very long time in a couple different scenarios as you go into college algebra, right? So because of this built-in minus, the h looks opposite in sign. So if I put these two together, that's going to give me my vertex. All right, so we'll look at another example in a minute, but let's go ahead and graph this one. The graphing part is exactly the same as the last example, right? How we found the vertex was different because we had this factored form, but the process of making the graph is the same. So we're going to put the vertex in the middle, and then we want to choose x values around that center point. Then we want to plug in these x values into our formula. Again, f of x is the same as y. So let's plug in a couple of these. Let's do -1. So we'll have -1 minus 1 squared plus 2. So that's like -2 squared plus 2. Or 4 plus 2 will give us 6. Okay, if I plug in 0, 0 minus 1 would be -1 squared. -1 squared is 1. 1 plus 2 is 3. Okay, you could do that for all of these. Plug them in. If I plug in 2, I'm going to use my trick, right? On equal sides, opposite sides of the vertex, I should get the same y. Okay, and if I plug in 3, I should get 6. Please feel free to check me. You don't have to use this trick. You can plug them all in if you like, but it does work. All right, so -1, I'm at 1, 2, 3, 4, 5, 3. here at 6, 0, 3. Here's my vertex at 1, 2. Right, that's my center point. This one is opening up. I should have asked you that ahead of time, but I forgot. And then 3, 6. All right, so we get a parabola that looks like that. Okay, I've got one more down here, just asking for the vertex. So again, here's the format. We want to find the vertex, so we need to identify the H and the K. Let's start with the K. In my opinion, that's the easy part. The K is exactly what we see on the outside here, right? So it's a positive 5. The H is the one that's going to have opposite sign. One way to see this when you have a plus is to think of it as a double negative, right? It's two negatives. We can combine those to make a plus. Right now, it's to my benefit to separate them so that I can kind of match this up, right? I have x minus a number. This is x minus negative 3 is my H. And so in that case, the vertex is the point negative 3, 5. All right, well, I hope this gave you a good idea of how to find the vertex, what a parabola looks like, and how to graph a parabola. I definitely recommend a little bit of practice on this. This is one of those skills that if you can get it down now, when you get to college algebra, you're really going to be at an advantage. It's going to help you out. All right, well, good luck. We'll see you in the next video.